Hello everyone. In this tutorial, I will walk you through the creation of a custom Bluetooth service on DA14592 SoC. Before we begin, let's quickly get an overview of Renesas DA1459 family. When working with Bluetooth Low Energy, data is organized in a structured way using profiles, services, and characteristics. Think of a profile as a collection of services that define a use case, like heart rate monitoring or a custom sensor application. At the core of every profile are services, and each service represents a logical function of the device and contains one or more characteristics. Characteristics have descriptors which provide extra information or configuration, such as enabling notifications or giving the characteristic a human readable name. Now let's see how the Bluetooth Low Energy framework works in Renesas systems. The BLE stack layers up to gap and get, and then adapter provides interface to the stack and executes the BLE stack internal scheduler and BLE interrupts, etc. The BLE manager acts like a middleman. It sends commands to the BLE adapter. The application uses out-of-the-box services from BLE framework and Renesas BLE APIs to initiate BLE operations or respond to BLE events. The application talks to BLE manager using these APIs. So in conclusion, an application should only have to interface either with Renesas BLE API library or the BLE service framework. In this Renesas framework, event handling is done in three levels. When an event occurs, it is handled by Bluetooth services. If not available, then the main application task should handle it. And if the target application does not have handlers for handling the received Bluetooth events, then BLE handle event default from Renesas API library is invoked. Now let's walk through how to create a custom BLE service using the Renesas BLE framework. For this, we will go to this guide and we will define a primary service with one characteristic and two descriptors, one for client configuration and one for a user-friendly description. To start, it's best practice to keep your BLE service code separate from the main application. This keeps things modular and makes your service easy to use. So let's get started. First, we define callback functions that respond to BLE read and write requests. These functions will handle data exchange and when the peer device accesses your characteristics. Next, create a structure to hold your service context. This includes the base service object, the callbacks, and the handles for each attribute. Then calculate the number of attribute handles you will need, one for characteristic and two for descriptors. You will now declare the service itself using a 128-bit UUID. Be careful here, any mistake in the UUID format will trigger an assertion. Next comes the characteristic declaration, where we define UUID, the permissions, read, write, or notify, and the expected data size. For example, if your characteristic only supports 1 data byte, writing more than that will fail. Then add descriptors, one for client characteristic and another for user description, which lets you add a human readable name. Once all attributes are declared, register them with Renesas ATT database so the BLE manager can automatically manage them. You will also calculate the end handle of your service and optionally set default values for your attributes. Finally, register the whole service with the Renesas BLE framework and link your read and write handlers. When a peer device sends a read or write request, your callbacks will identify which attribute was accessed and the handlers will respond accordingly. Now let's see the code structure of a custom BLE service through an example. We will download the example service from here. So we can download the zip from here and now open eScare Studio. Renesas has provided the Git repo with examples and README files for the DA1459 series. So this is the project. This header file sets up the framework for defining a Bluetooth service in our application. So here we have some macro declarations. And then we go for characteristic declaration, which makes it easier to configure a characteristic with a UUID, size, and permissions. And then we have some callbacks in here for the characteristic declaration. And here we have the service declaration macro registers, which registers the whole service within the BLE stack. Here the callback function types are declared. These three are the callback functions. Then we have data structures like characteristic config that hold the characteristic details like UUID, maximum size, then permission and all. Then we have a structure of service config which has the service details. And then we have some API definitions in here which are written for initializing the service and sending notifications to the peer devices. Let's move on to the C file now. This file implements the backend for custom BLE service that we declared in the header file, defining the macros, function prototypes, static routine, and then we have some user APIs. Here we have the first function, which is for sending the notifications. And then we have the second one to declare a Bluetooth custom service. It handles the entire BLE service lifecycle and calculates how many attributes and descriptors are needed. And the service has 128-bit UUIDs, and characteristics can be supported by the read, write, notify, or indicate function depending on their GET properties. And for the core logic of handling these GET events, we have read, write, and prepare handles that we saw above. So here's the event handler for sending. This one is for the read request, and then we have this one for write request. These handlers call app-defined callbacks to interact with the real-time data. And then we finally register the service. In short, this function handles all the work from initializing the service, declaring characteristics and descriptors, and registering everything to the BLE stack. This file sets the dummy UUIDs that you can see here. And these are the service UUIDs that you will be viewing in the application. Here it is setting the advertising data, and this is set to my custom service. And here is the BLE peripheral task where the BLE controller is initiated, and here we set the device name and declare a characteristic and custom service. So here's the custom service which is declared. This has the UUID of this one which was shown above here, and here the second service is registered. Now you can build and debug the project and then see the results on the application. Open the SmartPond application. As you can see, our device is advertising as My Custom Service, just as we defined in the application code. After connecting, we can view the list of available services. The first one matches the custom UUID we set in our first service and includes a characteristic with read, write, and notify properties. Scrolling further, we see the second custom service with its own UUID, exactly as configured in the code. We can now interact with these characteristics, enabling notifications, writing values, and seeing responses in real time. Now let's write some value to one of the characteristics. For this, open a serial terminal and start communicating over the COM port attached with the hardware. So set the baud rate to 115200 and the 8 bits of data, parity bit to none, and save the settings. To update the characteristic attribute value, tap on the up arrow, set the value. From here, select text and write the value you want to send and send it to DA14592 device. The value will be stored and the console will be updated accordingly. And with that, our custom BLE service is up and running. Thanks for watching and see you in the next video.